In this lesson, we'll tackle learning target number 3, changing information about one chemical into another using stoichiometry. Stoichiometry is a mathematical method that chemists use to change information about one chemical in a reaction into information about any other chemical they are interested in. Let's do an everyday example where we use the equation 1 marshmallow plus 4 chocolate chips plus 2 crackers produce 1 s'more. If I have 6 marshmallows, how many s'mores can I make? Remember that balanced chemical equations include the ratios or the amounts that you need to mix your chemicals in order to produce a reaction. In the above equation, for every 1 marshmallow, I can make 1 s'more. That means that if I have 6 marshmallows, I can make 6 s'mores because there's a 1-to-1 ratio. Using the coefficients in a balanced chemical equation in this way as a ratio is known as a mole ratio. This is how we can change the amount of one chemical into another. Now, mole ratios are called mole ratios for a reason. They work in the amount of particles or the moles of the chemical you have. They do not work with masses. So you can't say if I have 60 grams of marshmallows, then I can make 60 grams of s'mores. Instead of working with a straight ratio, we're going to write ratios as conversion factors. We're going to times by the chemical we want and divide by the chemical we have. And the numbers we use for our fractions will be the coefficients from the balanced chemical equations. I'll show you this in example 1. I start by writing down the number I'm given, 6 marshmallows. And I times it by what I want, which is s'mores, and divide it by what I already have, marshmallows. Then I check out the numbers that are in the balanced chemical equation. In front of the marshmallows there's a 1, and in front of the s'mores there's a 1. I include those numbers in my conversion factor. Remember, conversion factors are set up so that the units cancel out and you're left with what the question is asking for. So my answer is going to be in s'mores. Then I do the math. 6 times 1 divided by 1 gives me 6 s'mores. Try out example B and see how you do. Here's the answer for B. If I take 17 s'mores and times it by the conversion factor, 4 chocolate chips for 1 s'more, I need 68 chocolate chips. The exact same principle works with chemicals. Let's have a look at example 2. If I react magnesium chloride and sodium phosphide together, I'm going to get a double displacement reaction. If 9 moles of magnesium chloride is used, how many moles of NaCl is produced? I can predict that using stoichiometry. I start by writing down the number I'm given in the question. 9 moles of MgCl2. Now, if you're not given this balanced chemical equation, you guys know how to write it using our skills from Unit 2. Because I'm already in moles, I can go straight to converting into NaCl using a conversion factor. I want NaCl, so it goes on the top. I have MgCl2. Then I pull the coefficients out of the balanced chemical equation. If I take 9 times 6 divided by 3, I get 18 moles of NaCl. B asks, if we have 3.20 moles of sodium phosphide reacting, what is the theoretical yield of magnesium phosphide? The theoretical yield is the fancy term for saying what mass is made if the chemical reaction works perfectly. So here we're required to not only convert from one chemical to another, but then change the amount into grams. Let's start by writing down the moles that we're given. Because I'm in moles, I can times by a mole ratio and convert it into magnesium phosphide, just like we did in example A. My mole ratio this time will be 1/2. Now that I know how many moles of magnesium phosphide is made, I can change that into grams using the mass equals moles times molar mass equation. Using the periodic table, I determined that the molar mass of Mg3P2 is 134.87 grams per mole. My calculator tells me that I'm going to get 215.792 grams, but rounded with proper sigdigs, I'm going to get 216 grams as my final answer. Try out example C on your own. Pause the video here until you get your final answer. Here's the answer for example C. I'm given 10.0 grams of sodium chloride being made and asked how many moles of Na3P was reacted. Before I can convert into Na3P, I need to change my mass into moles using the mass equals moles times molar mass equation. Now that I'm in moles of NaCl, I can convert using a mole ratio. My ratio will be a 2:6 ratio. Remember, I get those numbers by using the coefficients from the balanced chemical equation. My calculator gives me a whole bunch of digits. Because I have 3 sigdigs in my 10.0 grams, and I used 4 in my molar mass, I need to keep 3 sigdigs in my final answer. Try out the mole ratio and stoichiometry worksheet you printed out with your note. This worksheet is not part of your assignment. It's practice to make sure you get the concepts. The stoichiometry practice problems for your Unit 3 assignment will be assigned the next day of class.